So we're now going to talk about part one of how to implement the async task barrier framework using RxJava. And the first part of this discussion will describe the API of async task barrier class that is provided for RxJava, which is ever so slightly different from the one that's used for Project Reactor because the types are different, having to do with how you wait for things to finish asynchronously. And then I'll briefly walk through a test program to demonstrate how you can use the async task barrier in practice and show you some very interesting little features that took me a while to get right. So the API for this contains methods that can be used to register, unregister, and then run tasks either synchronously or asynchronously. And these are the methods that are used. You can see that you register a supplier that will return a completable when its get method is called. And the reason for this is the easiest way to be able to wait for a bunch of asynchronous operations to finish. And then only after they're all done, after they're all complete, do you continue on. So it's basically a barrier synchronizer, if you will. The tasks themselves that are registered are stored in a list of suppliers to completables. And then the most interesting method, which we'll take a look at in just a bit, is going to run all the registered tasks. So all the tasks get registered first, and then the tasks get run, and they either run synchronously or asynchronously. From the point of view of the async task barrier, it doesn't really care, but the asynchronous part's the interesting part because this will ensure that the task barrier's main method doesn't return until everything is finished. However, run tasks doesn't block. It returns a single to a long. And if you want it to block, then you can call blocking get, and that will cause the calling thread to block until all the asynchronous task processing completes in the background. So this is a very useful barrier synchronizer that I use for testing. You could use it for other things too. If you wanted to do kind of gang scheduling that would then run asynchronously, and you'd only be able to keep going once all the asynchronous tasks either finished normally or they threw an exception. Okay, so what we're going to do now is I'm going to switch over to IntelliJ, and we're going to take a look at how you can use this API. So we're in my IntelliJ project. This is observable EX4, and this is the test program, async task barrier tests. And you can see we define a bunch of little helper methods that do various things, either running synchronously or asynchronously, and either throwing exceptions or not throwing exceptions. And you'll see why we do that when we talk a little bit more about how this whole thing works. So this method is called sync throw exception. The intent is to intentionally trigger an exception in a synchronous chain by dividing by 0, which will get an exception thrown. And you can see here, we just have a little single chain where we emit the numerator, then we divide the numerator by the denominator, which is 0. When things go wrong, we explain what exception occurred, and then we ignore the result that just says we're done. Here's the same logic, except this time we're going to asynchronously throw an exception, and we do that by subscribing this to run in a thread that comes from schedulers.single. Then we also have a couple of other methods that synchronously and asynchronously do not throw exceptions. So they don't divide by 0. Instead, they multiply 10 by 10. So this one runs synchronously, and this one runs asynchronously. Synchronously here just means running in the thread of the caller. So here's the test program. This is what we used unit tests JUnit to do. And you can see we do some interesting stuff. We create a bunch of local variables that will hold method references to the various methods that we're going to be testing. And we do this so it's easy to unregister them, because it turns out that every time you use a method reference directly, you get a different value. But if you store them in a local variable, then you can register them and then later come down and unregister them through the variable. And that's just a little Java trivia that you may or may not have known. So we go ahead and we register a bunch of these local variables, which are essentially placeholders for the method references. And then we, just for kicks, we actually deliberately register one method reference directly, but then we can't unregister it anyhow. And then we do the main part of the async task barrier. We run the tasks, which we'll see what that does shortly. We block the calling thread until everything's finished. And then in this case, two of these methods under test throw exceptions, and so they don't complete successfully. So the count that comes back here is a count of the operations, the tasks that ran successfully. So we just make sure that what we get back is equal to 2 because only 2 of them succeeded. We then go ahead and unregister everything except for the sync no exception method reference, which we can't unregister. And then we do the test again. And this time we should only get 1 completing successfully. So let's go ahead and run the test. And you'll see that when we run it, hopefully it works, and it does. You can see here we get a bunch of diagnostics, like we fail with divide by 0 for a couple of the cases, and we don't fail with the other cases where they don't throw exceptions. And indeed, it does have 2 tests complete successfully. And then we remove all the other methods that are being tested and only have this one finish up. So that's basically showing how you can use this particular capability. And if you go and look at all the examples I have throughout the GitHub repository for observable and also, of course, for Project Reactor's Flux, you'll see that I use the AsyncTaskBarrier all over the place. It's very helpful.